Hi there, this is Jake Nash, and welcome to Linear Algebra. So, if you've been on my channel before, you know that I've gone through some different math courses, and it's no different now. We're going to look at linear algebra here. So, the first thing that we're going to talk about in this video is vectors. I'm really going to go over the fundamentals of them, and we're going to go over some more detailed examples in a different video. But if we're talking about a vector, vectors have direction and magnitude. So you're going to want to know that. They have direction and magnitude. And we can write them with a lowercase letter with an arrow like that. An arrow like that. And if you see something like this, basically we can get the information about how to graph these. So if we had, for example, this vector, then we'd know that that's going to be 1, 4. This is where the arrow ends, and it starts at the origin. If it's in standard position, that's what this would be called, standard position. So it's going to start at the origin and end at this point. So that's how that works. And you can graph other ones, but you have to keep in mind that you would have to be told that it's in standard position. Otherwise, these vectors are actually equivalent. If they were like this, these would all be that also, but they're just not in standard position. So keep that in mind. You would have to be told that it's in standard position. Of course, you can have negative too. So if this was instead negatives for those, then it'd just be, like that. And then another situation that you could have is this. That's just going to be that. And really, zero, a vector of 0, it behaves oddly because it doesn't actually have any magnitude, and it can go in all directions. So technically it's going in all directions, but you're not going to ever display that with like arrows because it has 0 magnitude. And if you drew an arrow, then it would mean that it did have magnitude. So in case you don't understand direction and magnitude, if we're talking about the direction, it's the way that the vector's pointing, what direction it's pointing. Magnitude's going to mean how long it is. So there's actually some things that you can do with vectors. Different operations that you can do. But before we talk about that, I just want to add in a little bit of notation real quick. So if you see something like this, sorry, that's supposed to be an N. So what that's going to mean is that it exists in the nth dimension. Because this letter, that E looking thing, is going to mean exists in that dimension. So if you don't like that, like nth dimension, well, I just mean that I could replace n with any number, like 2 or 3, and it would be second or third dimension. So that's what that notation is going to mean. I just wanted to say that real quick. But there's different things that we can do with vectors, and we can add them. So there's addition that we can do to vectors. And here's what we're going to write here. So let me just use red. If the vector u and v exist in the same dimension, then u plus v is going to be the components of them added. So if you noticed in the example I showed before, we just had x and y. You can definitely have more than that. You could have x, y, z, or just u1, u2, u3, u4, all the way to un. So this is going to be what we'll get here. I don't know why I wrote it like that. I don't know what I'm doing there. And we're going to say all the way to un plus vn. So you're just going to add all the components. That's actually simple. So what we're just saying is if we want to add two vectors, you just add each of their components. So now, I said you won't have examples. I mean, I just mean not more like complex examples. But I will show one example real quick of that. So the vector u is going to be that. Vector v. And we want to know what those two vectors added is going to be. Well, it's pretty simple. You're just going to do 3 plus negative 2, 1 plus 4. And we get 1, 5. So that's the answer. That's not that bad. Now you gotta know one thing is that the order of addition is not going to matter. That's something that you'd probably already assume, but just to tell you the truth, it wouldn't matter if we did v plus u. It's going to be the same. So now, another thing that's a little bit funky that you might have to do, not only will you have to add them numerically, you might have to add vectors graphically, which might seem weird, but let's see how that might be. So let's say that this is our vector v, and this is our vector u. Well, there's a method that we can use called the tip-to-tail method that's going to help us do this. So what you do is, I just realized that looks like exactly the same. Sometimes it's hard for me to draw my u's. I'll just do a little thing like that so you know. So tip-to-tail method, what's going to happen is the tip of v needs to align with the tail of u. So this is the tip, this is the tail. So that means that we need to move u up here. And we can do that because these are the same vectors, it's just no longer in standard position. That's the only difference. So that's the first step that we do. You do a tip to tail. Then, after that, you are going to draw a vector that basically makes it into a triangle. And you're going to start that vector at the tail of the first one that we looked at, which was the v one, because we said this is the tip, and that's the only way that you could make it, but you just have to make sure that you don't do the arrow like that. It's going to be like that because the tail of it starts at the first one that you started with. I don't really know how to say that in other words, but that's the way you do it. So that's going to be the vector u plus v. So sometimes you have to do that. You're going to have to add vectors graphically. Now, something else that you can do is subtract vectors, but it's really the same thing as, it's going to be the same process as adding, because what you end up doing is just adding the negative instead of subtracting. So let's say that once again, this is our vector v, and this is our vector u. What if we wanted to subtract them? Well, you instead would just add the negative instead of subtracting. So that we'll do v plus u, and the order that you do these, u plus v, v plus u, like I said, it doesn't matter. But we're going to do v plus negative u. Negative u is just going to be like flip that thing backwards. But again, we need to do the tip to tail method, so it's going to end up here. And then this time, this is going to be the vector that we'd get. That's the answer of them combined. So that's how that works. Now, let's just talk about a few properties of vector addition, just so that we know that this is true. Now, the first one is what I already said. If you add two vectors, it's the same as if you do it the other way around, so if you switch them. So it doesn't matter what order you do it in. The next is you can group them in a certain way like this, and that's still going to be equivalent to this. The third one's going to be that if you add 0 to a vector, you're still going to get that same vector. And then the last one is if you add by the negative version of the same vector, you get 0. So these are things that you'd probably already assume, but we're just telling you this because it's good to know that, yes, it is true, just in case. All right? So we talked about how to add and subtract vectors. Now, what about multiplying and dividing? Well, multiplying, it's going to be a little bit different what we're going to do. Dividing is just not something that we do, so at least at this time. But so some things that are going to be true for scalar multiplication is that if you multiply by a constant with something like that, all you can do, or what you can do, is just distribute that constant like that. But additionally, if you have a vector that you're distributing two constants, you can still do that just the same. And then you can change the order like this. And then the last one is 1 times the vector is still going to be the vector itself. So again, these are things that you probably just assume. But the key thing is that this time, if you multiply two different vectors together, it's not going to just be all their components multiplied together. So that's something important. That's not what we're going to do. So instead, you're going to essentially add all of the products of each of the components. So we're going to look at that. That's going to be called dot product method, and it's actually something that we're going to look at in the next video. So, yep, I got a little bit off track there. I don't have the most organized notes for this first lesson, but I'll do better in the next ones. But I was about to get into the next lesson on accident, so that's why I paused briefly. But that's a good place to stop. That's a good introduction to vectors, so I hope that helped, and thanks for watching.